Now that we have an understanding of how the cluster hunting algorithm works, we're going to explore a dataset relating to the 2012 Olympic Games men's road cycling race using the algorithm. To do this, we start a new experiment by clicking the Start New Experiment box, which gives us an option to choose our clustering method, and we want to choose geographical analysis. This will reveal a series of parameter input boxes which we can use to specify each of the parameters to control the algorithm's performance during the run. The first input box is the input file, which has selected the top file available for use and is actually the one that we want to use, so we'll leave that one set to the pre-selected value. The second input box is this search term input box, which allows us to identify events. This is a widening search where each term in a comma delimited list is searched for. So if any one or a combination of the terms is present in the text of the tweet, it will be identified as an event. We're going to use the last names of all the British cycling team: Cavendish, Wiggins, Froome, Stannard and Miller. We're going to use Cav here at the beginning, which is a nickname given to Mark Cavendish, and cycling and race are a couple of catch-alls to make sure that we catch any tweets that are referring to the road race. Any tweets that are identified as events are considered in relation to all geographically located tweets during the run of the algorithm. All geographically located tweets will make up the population, and all geographically located tweets that contain one of these search terms or a combination of these search terms will be marked as the event to be considered against the population. The next input parameter box is the radius minimum, and the one below that is the radius maximum, and the one below that is the radius increment. These three boxes specify the size of the initial search circle, the maximum size of the search circle, and the increments between the minimum and maximum. We're going to use 500 for the minimum radius, 5,000 for the maximum, and an increment of 500 to move between the two. We need to consider these search settings in relation to the actual area that we're searching. If we're searching a large area, a large geographical area such as the United States or a continent such as Africa, search settings of 500 and of 5,000 and an increment of 500 as we have here would probably take quite a considerable amount of time to complete such a search. It may be better to identify smaller areas of interest and do a detailed search in those smaller areas, or maybe consider adjusting the settings so that you're actually doing a coarser search across the data set. The next parameter is the overlap parameter. We discussed this in quite a bit of depth during the discussion of the algorithm and the algorithm summary, and I identified there how having to a lower setting here can lead to a very detailed search and reduced algorithm performance, whereas having to higher setting can actually lead to gaps in the search area and the potential for missing data or not considering data during the algorithm's execution. So we're going to use the default parameter, which is 0.5. This is a good value to use. The search circle moves at a reasonable rate across the search area, and it considers all of the data. It covers the whole of the geographical area. The final parameter is the significance threshold, and this is the parameter which determines whether the difference between the observed and expected cases is significant. The lower this value, the more stringent the test. We're going to use 0.0099, which is the default value and should be suitable for most algorithm runs, for most explorations. Once you've got all your settings filled in, all your parameter values filled in, we start the clustering by clicking on the Start Clustering button here.